Good morning. Good morning from Hong Kong. It's December 13th, 2022. This is episode 44 of Asia Society Hong Kong's coronavirus updates. I have to confess, when we started this program, February 14th, 2020, I really never thought that we would go this far, episode 44. I really thought it would be 10 episodes or maybe a dozen at the most. But the coronavirus, SARS-CoV-2 is still with us, almost 3 years to the day of, we're coming up on Christmas. And I believe it was about 3 years ago, we first heard of something that was happening in Wuhan, China. And so much has happened in this last 3 years. And one of the things that we want to talk about today is really about how effective are the new vaccines. Today's topic is about the new vaccines and lessons from the United States. We're really delighted that we have Dr. Rodda, a Postdoctoral Scholar, Department of Immunology at University of Washington, with us today to address some of these issues. I was in the States recently in the fall, and I gotten my fifth shot, third booster, and it was the Pfizer bivalent. And then a few weeks later, while traveling in Europe, I got COVID. But maybe because of the vaccination, my symptoms were very mild. Within 5 days, I was testing negative. So we have a lot to learn. And in Hong Kong, in a few days, I think the government's going to be the rolling out of the new the bivalent vaccine will be available to the general public here in Hong Kong. So we're going to use this opportunity to hear more from Dr. Rodda about what's lessons learned from the U.S. So with that, I'm going to turn it over to Dr. Rodda to give us a short presentation, and then I'll come back with some questions, and then followed by Q&A from the online audience on Slido. So, Lauren, floor is yours.
Great. Thank you. Thank you for having me. I'm just going to pull up my slides here. Thank you so much for having me. I'm excited to talk to you. I'm talking to you from Seattle, Washington in the US. We're going to talk about, share some things that we've learned about SARS-CoV-2 vaccines and their efficacy. And so I just want to start by putting up, this is the cases by region across the world. And that we've had quite significant waves here, and we are seeing an uptick right now. And so I think this is just incredibly relevant as we go into this next season. And I think it's pretty reasonable to think that we're going to see another wave of cases. So I just wanted to back up and just briefly go over how that SARS-CoV-2 infection. So back at the beginning of 2020, when SARS-CoV-2, the virus that causes COVID-19, sort of started, it made the jump into humans. The only immunity that we were potentially going to be able to rely on was infection-induced immunity. However, infection can cause really severe disease. So that's what I wanted to talk about first. So in 2019, the human population had very little cross-reactive immune memory to SARS-CoV-2, and that meant that most people were susceptible. That combined with SARS-CoV-2 being highly transmissible. So here on the left is a graphic showing, it's called the R naught, but this is a number is assigned to viruses, and it communicates for any infected person, the expected number of people that will be infected by that person. And so you can see that SARS-CoV-2 that causes COVID-19 is sort of in between what we think of the common flu, influenza, and something like measles, which is much more infectious. That being said, it is reasonably highly transmissible. And so with so many people susceptible, we had a huge wave of people having severe disease, which includes respiratory distress, organ failure and can cause death. And even in the group that, while the majority of people had mild infection, even mild infection can cause long COVID and or post-acute sequelae of COVID-19 or PASC, which is ongoing symptoms for months after having been infected, which is all just to say that it's a good thing that we have vaccines and you don't need to get infected to have any sort of protection. But our first study, so back in 2020, we were studying different disease, but we were studying immune responses, and we were particularly interested in persistent immune responses, ones that would last for a long time and keep protecting you. And I just wanted to just a brief dive into some immunology, because this is sort of my field. There are four major arms to antiviral immunity and immune memory. So you have your antibodies, and here's a little graphic of SARS-CoV-2. Antibodies can coat the outside of the virus and prevent it from being able to infect cells. Memory B cells can live for long periods of time, and then if they see the virus again, they'll rapidly reactivate and really boost up your level of antibodies. Memory CD4 T cells can produce these things called cytokines that can really promote an antiviral response, innate response, as well as and supporting the memory CD8 T cells, which when they get activated, they can kill infected cells. So all of these arms together all of these arms work together to help protect us. And these form your immune memory. And this is really important because, as I said, humans had very little immune memory prior to this, to SARS-CoV-2, prior to the pandemic, and so the difference is really, really stark. And I'll show some data here. So in blue, the blue line is so this peak here is cases, and the blue line are people who got infected in 2020, and then the light blue line here is people in that first group who then got reinfected, and as opposed to the red line is people who weren't infected early in 2020 and then got infected at the same time. And so this difference between the red line and the light blue line is the amount of actual protection that people got from being prior infected. And so translated, at least in this study, to about 84% lower risk of reinfection. So I can show some data later if people are interested, but that was our first study, and we found that natural infection induced antibodies, it induced memory B cells, it induced memory T cells. So you got multi-arms of immune memory, really the classic that we were hoping that the virus would induce. And then we had this rapid production of COVID-19 vaccines, and really this generation of vaccines has just exploded, which is fantastic. The field is exploring these new ways to vaccinate, and hopefully we just keep getting better and better at it. But I just wanted to mention, because I get this question a lot of people being unfamiliar what an mRNA vaccine actually is. So I think maybe you've already gone over this many times in this program, but again, the mRNA vaccines just contain a piece of a code for one part of the SARS-CoV-2 virus. So what's really great about these vaccines is that they cannot cause COVID-19. They're just a training exercise for your immune system, and allows your immune system to practice on this vaccine, build up all that immune memory, all that good immune memory, without any risk of infection or death. And so we wanted to see how well this worked, and so this is from our work. And here I'm showing on the left antibodies. So this is quantity of antibody over time, and so these days on the x-axis, and what you can see is after initial vaccinations, the first two vaccinations here, which I thought I had graphic there. But anyway, you get a huge burst in antibody, which we expect. But then we saw that antibody really dropped off by 6 months here. And so I think that's something that other groups have seen too. And it's really important that individuals who had just been vaccinated with the first 2 doses of an mRNA vaccine, by 6 months, their antibody has really fallen off. But a 3rd dose seemed to boost this up. And this is very early after a 3rd dose. And I'm going to show you, we just got some later data, which is sort of more informative. But we also looked at memory B cells. So again, I'm going to show data just a couple of slides, but antibody provides this sort of first layer of protection. It generally protects from symptoms, and then, of course, also severe disease and death. But memory B cells and memory T cells, they reactivate slightly slower than having the antibody that's just already on board, but really quite quickly. And if those can get reactivated, that really is your protection from severe disease and death. So having all of these arms, they provide this multi-layered of protection. And what's really great, you can see these memory B cells, they kept increasing up to 3 months, right? So they were generated by that first 2 vaccines, and we just kept making more of them. And that CD4 T cells here, the memory T cells, mostly were generated by that early time point after the 2nd dose, but are well maintained for 3 months. So the vaccine is inducing really maintained, or even better, increasing amounts of these cellular components of cellular immune memory, even though the antibody is decreasing. And what that translates to in terms of efficacy, so there's a lot of numbers on this slide, but I can just go through. So the Pfizer, Moderna, mRNA vaccines against the original strain were about 70 to 95% effective against infection, and at least 95% effective against hospitalization and death. And so this is vaccine efficacy on the y-axis and time over time. And so you can see these curves. Even at 7 months, the mRNA vaccines are way up here. The Johnson & Johnson adenovirus vaccine was a little bit less effective, and the Sinovac, which I know is one that was used a lot in China, is a little bit less effective. This 83 is a little bit high, is more like 60%. Again, this is against infection, so more this first graph here. But what's really remarkable is, even though these start to drop off with time, again, as we saw those antibodies drop off, still hospitalization and death is kept, efficacy kept quite high. And I just wanted to throw this up just as a further emphasis that the power of vaccines. So we have the ability to measure how many excess is called excess death. So based on the mortality over time in years prior to the SARS-CoV-2 pandemic, they've been able to measure how many deaths the pandemic has caused. And then with the invention of SARS-CoV-2 vaccines, they, in this study, estimated how many lives were saved. And here they estimated almost upwards of 20 million lives were saved by vaccines. So they are efficacious, and they are really saving a lot of lives. And that's the difference here, this blue and yellow or light green curves, the difference between the red and the black lines. But then I mentioned that the booster, so now we have had the original doses, and then the booster is now available, and now 4th boosters, as I was saying, and bivalent. But here we were able in our study to look at the 3rd booster, and I said that the antibody titers went up again. This is antibody specific for SARS-CoV-2 against the 3rd. And at 3 months, we still saw that it was higher. And at 6 months after the 3rd booster, so here's the significant difference here. 6 months after the 3rd booster, it was better than 6 months after the 2nd dose. So getting that third booster didn't just give that short burst of antibody, it really improved the durability of your immune responses. So I think this and other data similar to it really is good evidence that we should all be getting a third booster, even if you're only able to access one for the original strain, and we'll talk about Omicron in just a second. And I just wanted, as comparison, most of our study was about comparing people who had been infected and then vaccinated versus had been vaccinated alone. And what we found is that it's in terms of antibody, at least antibody and B cells, 3 exposures was pretty equivalent. So here, an individual who has been vaccinated 3 times had a pretty similar amount of antibody as someone who'd been infected and then vaccinated twice, which was pretty similar to someone who had been vaccinated twice and then had a breakthrough Delta infection. So just to say that prior infection was also really helped by vaccination in terms of the amount of immunity that, immune memory that individuals had, and that 3 doses was important. But now we're in the era of variants, and we've seen many waves here. I'm showing the curves in the USA, where we first saw Alpha, then Delta, and now these many branches of Omicron. And I just wanted to throw up, this is a great resource, covariance.org, where they're tracking these for different places. So we have Hong Kong and China as well. The data is a little bit less sequencing available. So the data gets a little bit more mountainous, so to speak. But I just wanted to put this up, and we've talked a lot about BA.4/5, I think, in the news, but now we have even new strains out that we know a little bit less about, but they largely share a lot of the same variants. So here is a phylogenetic tree of the different SARS-CoV-2 variants. And so each dot is a different sequence that's been detected, a viral sequence. And this down in the bottom left corner is the original strain, the original sequence that when it's SARS-CoV-2 was first detected. And then these branches are the different variants. And so in blue, you can see Delta made sort of its own branch. And if you're not used to looking at these, the distance the distance between dots, branches that are farther away on the tree are more different in sequence. And so what we can see here is Delta. And what was really remarkable is Omicron came off an entirely different arm. So really, really far back off the tree. Those branches are really, really far apart. And now Omicron, a lot of the variants, the current circulating variants are all versions of Omicron. And I find it very interesting. Where did these variants come from? What is sort of pushing them, or how are they evolving? And so some of the things that we know is that Alpha, the Alpha mutations, the mutations in Alpha increase the binding to the human receptor ACE2, and they also suppress some of the early immune response. And so that just a short amount of suppression allowed it to replicate a little bit better, and that increased transmissibility from having more virus in the nose allowed that variant to take off. And then Delta was able to replicate faster, and that really had an enormous impact on transmission. A little bit of immune evasion there, but not nearly as much as Omicron. Omicron had a huge number of mutations, so more than twice as much as the other variants, and we saw significant antibody evasion. So these latest Omicron variants seem to be really pressured by immune evasion, and we still don't really know where it came from. There are a couple hypotheses. I think the leading one at this point is that in immunocompromised individuals, the virus can evolve under slight pressure from the immune system, because the immune system isn't as effective, and that allows the virus to generate this huge amount of mutations, but still under investigation. And I just wanted to mention there's really great work trying to understand not just these variants, but what might be next and what are we worried about. So each of these dots and these letters and numbers are potential mutations. And each of these graphs is for one of the major monoclonal antibodies used as treatment for SARS-CoV-2. And what this is showing is that on the y-axis, how much antibody escape that mutation can cause, and then on the y-axis, and on the x-axis, the frequency that's been detected, that particular mutation has been detected in all of the sequences that are available. And just to draw your eye on the far right, so first, the number of dots that you can see in the plot that aren't on an axis are the ones to be worried about. They've both been detected in circulation and can cause some immune evasion. And you can see these first two have quite a few dots, but when you use them in combination, there's very few. And so this is really the power of not only our own immune systems that doesn't just have two types of antibody, we have lots of antibodies. So again, the power of vaccination, but here are these drug treatments, even though some of them are having some issues with the variants, we can combine them and induce better coverage. But here, for example, in this study, they identified K417N as being both highly found in sequences and highly evasive. And this is one of the mutations in Omicron. So I think this is not great news for this particular treatment, but we have others. And these are just monoclonal antibodies, lots of other treatments available. But just sort of the importance of the variants. And here is just last little bit of data. In the colors here, this is the ability of antibody to neutralize. So the original strain, so after vaccination, good neutralization of the original strain, but it's almost entirely gone when tested against Omicron. So Omicron has really been able to evade at least the neutralization aspect of antibodies. However, remember, you have those multiple arms of immune memory after vaccination. And so memory B cells here, it's showing fold change. So ability to recognize the variants versus the original. And so these are very close to 1, meaning no change. And here for the T cells, some of them have absolutely no change at all. So B cells are slightly affected. T cells here, Omicron on the right, are also slightly affected, but they have 80 to 90% recognition of Omicron as well, as compared to the original strain. So our hypothesis was that, this would translate to Omicron would probably cause a lot more cases in people who had some prior immunity, but people would still be protected from severe disease and death. And that's actually what we see. So during the Delta wave, here what's plotted is the number of cases on the left and the number of deaths on the right that were detected in people who were vaccinated versus unvaccinated. So this is showing really, again, the efficacy of the vaccine. Vaccinated individuals were sixfold had sixfold fewer cases and 16 times less risk of death here. And Delta did not really evade antibody detection. So if you were vaccinated, you had antibodies, memory B cells, and memory T cells all protecting you from both symptomatic infection and death. And then with the Omicron wave, and I should have prefaced that this is data from the US. From the Omicron wave, what we saw is that people who were vaccinated all of a sudden were sort of this population that was susceptible again to getting infected, and that did really contribute to the wave. There's still less less than unvaccinated people, but not as big a difference. However, if you look at the deaths, they're still significantly protected from death for being vaccinated. So even though everyone has heard a lot about breakthrough infections, it doesn't mean that your immune system is worthless, that it didn't work. There's the protection from severe disease and death, which is really our primary concern. Certainly nobody wants to get sick. And so what we think that this is reading out is the fact that antibodies are evaded, but you still have these arms of immunity to protect you. So this is just my last slide, but just looking forward, I'm happy to talk also about the bivalent vaccine. We have very little data at this point, but what we do know is that not very many people have gotten it. And so I mentioned that I think it was like 33% of people have gotten the third booster, have gotten additional doses. And it's probably actually even lower than that. Bivalent hasn't been available very long. And so hopefully we'll get more uptake as time goes on. We do see that after a month, we see better Omicron-specific antibodies. But again, so antibodies can stick around for about 1 to 2 months. But after that, you really need cells to keep generating them. And so what we need to do is look past 2 months to really see if there's going to be durability of these Omicron-specific antibodies. And then the other exciting type of vaccine on the up and coming and is now available, at least for emergency use in China, are intranasal vaccines. And the idea here is that since the virus enters through your nose and your respiratory tract, that if you could have antibodies, if antibodies really are trying to mop up virus right at the beginning, if you could have antibodies right there and you could have the immune cells right there, then maybe you would be better protected from symptomatic infection. And then also, hopefully that could help reduce transmission, which would be fantastic. And I think these are really going to be focused on the most vulnerable populations for that reason, and also the reason that intramuscular vaccines are still very protective. Intranasal vaccines have their own issues, and I think the flu version of an intranasal vaccine, which is approved for children, is evidence that they can work. So with that, I will stop sharing and see if people have questions.
Thank you. Thank you for all that really great information. I know there's a lot to digest, but I kind of wanted to start off by asking you about the intranasal, because that seems to me one of the latest development. We're hearing it here in Hong Kong, a recent story early December that intranasal has been introduced for emergency use, as you mentioned, in China. And also China is slowly opening up. Zero COVID is no longer the policy. And then, so I'm kind of curious about the intranasal. I think I just read about the Hong Kong U, the study, the emergency use. It's done with Xiamen University and Beijing Wantai Biological Pharmacy. And they said it's going to be, I think, planning to make about 200 million doses in the next 6 months. And you have mentioned there's been talk of it. I mean, finally, New York Times has been mentioning that. So can you, and you also alluded to the talking about the nasal vaccine for flu. So it's nothing new. So, and because of China's large population and, we've gone through a different journey in that Hong Kong Omicron has been with us. We've had a severe fifth wave in that we saw in earlier this year in March. China is opening up. I'm sure cases are going to go up. So can you address that intranasal, how that might be a game changer for as a vaccine for maybe China?
Yeah, that's great. Yeah, I think the critical first point is that I haven't seen, and I don't think anyone has seen data on this particular intranasal vaccine. So all I can speak to is what has been published, which is an intranasal vaccine for flu, and that was made a couple years ago now. And what they found there, so I would love to be optimistic, and I am optimistic about the intranasal vaccine. I think conceptually, that's absolutely the way we need to go, and it really conceptually could protect from transmission in a way that we haven't been able to achieve with the intramuscular vaccines. But creating normally how we create a vaccine, you have to have the antigen, the part of the virus you want to train the immune system against, and then you need to have some sort of danger signal or some sort of inflammation to trigger the immune system to say, oh, this is a foreign, this is a bad thing I need to respond to. And that's just a hard thing to do in the respiratory tract without causing really severe problems. And also you need to get the instead of injecting it, in the arm, which just goes right into your system, it needs to get across the barrier. So the method, and I'm not sure what method the Chinese vaccine is using, but the method that has been used is to take a live attenuated virus. So that's what the flu vaccine is. And that seems to have been safe. It's approved for kids who don't want to have a needle. And I'm, anything that gets more kids vaccinated and for both COVID and flu is fantastic. So what we saw with that is that it was equally effective in kids against a matched flu strain, but in adults it didn't work very well. It seemed to have good efficacy the first year, and then had some problems. A couple of years it was mismatched strains, which is not the fault of the vaccine, but yeah, it is no longer approved in the US, at least for use in adults. Not for safety reasons, but for efficacy reasons. So I think that's really important, that it at least if it's a version similar to flu mist, that at least the flu mist was safe. But yeah, I'm very excited to see data on that, because I think it'll be the first in the world to do this, and that's really where the vaccines are going. US has many intranasal vaccines in trials right now, so that's absolutely the strategy. I think that they got the right idea there.
Well, I guess in doing the research, it said there's about 100 nasal delivery of COVID vaccines are under development, and 20 is being tested. So I think we can stay tuned on that. But I just thought it was interesting in December hearing about what's happening in this part of the world. So stay tuned. But one of the things I wanted to ask you, really, you had mentioned in your presentation about long COVID. And long COVID from the first strain, from Alpha, I guess, was, a lot of people are still suffering from it. But is long COVID also part of something that are we seeing in Omicron, or is it is just a side effect of maybe Delta and Alpha?
That's a good question. I think conservatively, I don't know the answer. I'm not sure. I mean, at this point, we're a year out from the first Omicron cases, so that answer should be out there, but I just don't know. I think it's interesting that it's it seems like it's a combination of causes, and so it's been hard to track down whether there's any sort of predictors of who's going to get it, and whether it could be headed off or what even the treatment should be, but it does seem like it's a combination of maybe not a combination, but that different people might have different things that are causing it, and so that's made it challenging to track down. But yeah, I would be surprised if Omicron doesn't cause it as well. I think it's a combination of the damage caused to the lungs, as well as immune responses not turning off as effectively as they should in a few cases. But Omicron does infect more the upper respiratory tract, and it is so there could be reasons why Omicron. Hopefully, I hope that's true.
Well, 2 years ago when I was doing this program, the big big thing that we were hearing about was herd immunity. This is, I think, right before we got the vaccine. Everybody here was trying to get herd immunity of whatever percentage, 60 to 90%. But right now, it seems to me, right now, talking to you, your research on the hybrid immunity. So, can you talk about, what is what is the best option, one or the other? Is herd immunity even relevant right now? Because here in Hong Kong, many people are getting COVID and then getting the vaccination. So are we heading toward proponent of hybrid immunity, and then forget about I guess herd immunity versus hybrid? What is your take on that?
So I think that herd immunity is defined as a community having sufficient immunity to start decreasing the number of cases. And I think that obviously that would be the goal, is to reduce the number of people that are getting it. And the fastest way to get there is vaccination. And vaccines, we know, are less effective in the elderly, who are also more at risk. Which is not to say that people who are older shouldn't get vaccinated. It absolutely is still beneficial. And we had a wide range of ages in our study, and we saw that we didn't see a correlation with age in terms of responsiveness. So I'm certainly a proponent of that. But I think there is that herd immunity reason to be vaccinated, even if you're not in a high risk group, because that helps protect the people around you. We were talking before, I'm going to go see my 97-year-old grandmother for the holidays. And I made sure to get, I got my bivalent vaccine, which is available here, and my flu vaccine, because I want to be as protected as I can be, and make sure that I don't bring it to her. So I think herd immunity, in the sense of, can we ever be vaccinated enough to make SARS-CoV-2 go away? I don't think that is reasonable. SARS-CoV-2 is mutating almost as fast as flu. It doesn't have the recombination of flu, but we're seeing that there's a huge mutational space that it could explore in terms of being a viable virus. So I think that it's endemic now. It's just, it's not going to be able to be stamped out in that way. But the idea that we could get cases per year down, and therefore deaths from this down, I think is absolutely reasonable. And that is going to come from a combination of vaccinations and, unfortunately, so many people still being infected. You mentioned hybrid immunity. And so hybrid immunity is sort of a confusing term, but it's this idea that if you combine, if you've been infected, does vaccination, does being infected and vaccinated give you a different type of immunity than being vaccinated alone? And what we saw is that people who had been infected in our study, infected first, had slightly different T cell responses to people who had been vaccinated. And in fact, they had more of this interferon gamma cytokine, as well as IL-10. And we don't know right now, in a different study, people who've been previously infected and vaccinated versus vaccinated alone were better protected against reinfection. So there is this correlation that maybe there is better protection from that, but we don't know that the differences we saw are actually causative of better protection. What we did see is that if people who had been vaccinated alone got a booster dose, their quantity, the amount of immune memory was normalized. And so because of the risk of severe disease and death, I would just highly encourage people to get boosted. Importantly, to wait at least 3 months between doses to really get the maximal benefit from a boost. So certainly not a proponent of people getting infected, but what our study did show is that if you've been infected, you still get benefit from vaccination. So to combine those two is great. If you've been just vaccinated with the first 2 doses, get that 3rd dose. That's sort of what our study said. Yeah.
Great. And then the other question I wanted to ask you to address is the COVID, the vaccination for COVID, taking it together with the flu vaccination. I remember when I was in the States, when I got my bivalent vaccination, they were encouraging that I also do the flu at the same time, but I chose to do it when I came back to Hong Kong. In fact, just about a month ago, because the flu season in Hong Kong is, around, rather than do it earlier in September. So, is there what is your thought on that, and in terms of effectiveness, or do it together or wait in terms of a later for the flu vaccination?
Yeah, that's a great question. And I got that a lot from both journalists and family members. And I got mine together. So I think the recommendation, there's a couple things that go into this decision. The recommendation to get them together largely comes from it's more likely that you will get both of them if you do them together. And the bottom line is getting vaccinated at any time is better than not getting vaccinated. And so the idea that if you wait, then you might forget and then you might not get it is much worse than it means you just don't get any benefit than if you do a little bit on the early side, and your immunity for the flu vaccine has waned a little bit by the tail end of flu season. So something that we haven't seen yet for the COVID vaccines, but something we see with flu is that after the vaccination, you have about 3 months of really good protection. And usually that covers people pretty well for flu season. But flu season's been a little bit less predictable since we saw that social distancing and masking was incredibly effective against flu and RSV as well as it was against SARS-CoV-2. So some people think that that's why we're getting a bigger wave now. So the reason to wait is to try to match up your 3 months of best protection. You still are protected, but just best protection with that wave. And so I think that's reasonable as long as you make sure that you do actually get vaccinated. And I think the other piece, so 2 more pieces of things to keep in mind. If you get them together, it doesn't impair either vaccine. It's perfectly effective to get them together. Well, perfectly, but there's no evidence that it is any less effective to get them both together. And in fact, good evidence that they work fine. And then the other piece is just, again, I'm going home for the holidays. If you're going to see older relatives, you might want to get it on the earlier side. And I also got it on the earlier side because you want to make sure that you're doing your best to help protect them as well. So those are the sorts of things that went into that I think should go into the calculation. Yeah.
I'm going to Slido now for questions from the online audience, and this is related to what we just talked about. What is your projection for this year's flu season in the United States? How does this year's vaccine match up to the flu viruses now circulating?
So the word from the CDC is that it's matching up pretty well. We don't have efficacy data yet. Last year's was pretty low, but it was a little hard to tell because their cases were so low, which is fantastic. So the hope is that it's going to be the vaccine will be pretty good. Uptake of the vaccine is still relatively poor. In the US, it's in the teens to 20%. And so unless more people get vaccinated, it doesn't really matter how good the vaccine is. So my hope is that people will get the flu are already worryingly high, and I think there is good evidence that if it's been a couple years since you've been exposed or have the vaccine, that you're at higher risk of worse disease. So hopefully people will get vaccinated.
You mentioned earlier that, I think last year, I guess, maybe during the flu season, because of the mask, and some states had mask mandates and so on, flu season was not as severe. But in the US now, everybody is basically maskless. Here in Hong Kong, everybody is still wearing masks. So maybe our flu season is going to be not as awful but are you worried about the flu? Along with, a year ago, I know there was concern with getting COVID and flu together, but is that something that's not, it's just going to be par for the course now going forward, that we're going to get COVID and, COVID vaccines as well as flu vaccine? Is that the trend moving forward?
Yeah, I think a yearly vaccine is definitely where we're going. And I think that if it improved uptake to have it be, that every year you get both together, then I think it'd be reasonable. The waves with COVID have been reasonably cyclical, but they've been shifting. So it's not clear that there's a seasonality to COVID the same way there is to flu, or at least we haven't nailed it down yet when when the time is that you would get the vaccination. In terms of co-infection, both SARS-CoV-2 and flu induce a really strong Th1 antiviral response, which use a lot of the same defense mechanisms. So I think it's unlikely that if you were currently fighting off flu or COVID effectively, that would a second virus would not effectively be able to infect, because the system's already going. Now, is it more of a concern? Absolutely, for people who are not effectively fighting it off. If you already have severe disease and you get that infection on top, absolutely that can be a concern. But yeah, I think we're going towards yearly vaccines. The hope would be that with this bivalent vaccine or a variant-specific vaccine, that since SARS-CoV-2 mutates quite a lot, it's not as variant as flu. So that maybe we could do every couple of years, which would be great. We still, I don't think we've still seen what the world looks like with everyone having pretty solid basis of immunity. When that's the percentage of the population that's truly susceptible is a shifting thing with variants and things like that. But if people really could get that fully vaccinated or get that booster vaccination, we're at, I think, 70% of the world has had one vaccine. There are still huge swaths of the human population that haven't had a vaccine. So and lots of people have been infected, but yeah, if we could be immediately there, I think the state of the virus would be very different.
Now I want to address the variants, and I know when we started this program, it was at the beginning it was the Alpha and then the Delta, and some of them came out of for example, South Africa and India or other parts of the developing world. And then, it just kind of caught on and all the world got it. So right now with Omicron, it's the prevalent, it's the variant going around right now. This is the majority of it. With China opening up, the question from the audience is it likely, there is obviously going to have a wave, Omicron wave or whatever. But given China's sizable naive population, many of them have not gotten COVID. Do you expect new variants to come out of China? And is that something, will the new variant be getting milder and milder, or is it still something that we need to kind of watch out for?
Yeah, that's really interesting. I think so. I think the waves I was mentioning before, the waves have really been associated with a large percentage of the population becoming susceptible or being susceptible. So the first Delta wave was largely unvaccinated people, and so you could see that vaccinated people really didn't get Delta, and so that suggested that there was still a large percentage of the world that hadn't been, infected, and there was that niche for the virus. And then with Omicron, because it evaded at least enough of the antibody response so that people could get reinfected, then all of a sudden there was a huge swath of the population now susceptible to to infection again. And so I think that in terms of an opportunity for a variant to take hold and really cause a large pandemic, having a significant number of people all at the same place, all susceptible, is certainly risky. As far as I understand, significant portion of China has been vaccinated, so I wouldn't say they are naive. The vaccine will provide some immune protection, and if they've been boosted, and I know they're encouraging at least older population to get an additional dose now, the intranasal vaccine. Now I don't have data on that, but if it was the booster dose, then that would again help protect them, not only from Omicron, but if the next variant as well. Because what we can see that even if you've never seen the variant, if you have high enough antibody, then you'll still be protected. So I think that's something, again, vote for vaccines. So I think we'll see that in terms of new variants. It's still unclear where the other variants came from, and people are really looking hard at that to try to be able to predict where the next one's coming from. In terms of Omicron, one of the hypotheses was immunocompromised individuals. One of the hypotheses was that a low level of circulation in a population we weren't well monitoring in terms of sequencing. Now, I wouldn't think that China would be in that group. I think they're doing significant sequencing, but like the reason why we associate Omicron with South Africa is not probably because that's where it came from. It's just because they do incredible amounts of sequencing, right? So if anyone's going to detect it, it's going to be South Africa. So we'll have to see, but just because the population has lower immunity, I don't think that necessarily means that they will be generating new variants. So hopefully not, but they're certainly susceptible to Omicron, and I think there's a risk of that being a very big wave.
Well, I think having done this program for almost 3 years, like every country who felt that they were protected, all in the end, the coronavirus come out and bite them. And for a while they are here in this part of the world, we thought we were doing a great job, whether you were in Korea, Taiwan, Singapore, or China. We thought it was not going to hit us as severely as the Western country. And coronavirus has certainly proven that we are all susceptible, and we are all, no one is, immune from this. So this is one of the lessons that I've learned from this last couple of years. I think we are running out of time, and we have one more last question from the audience that I want to ask you. What do you say to people who are still hesitant to be vaccinated? And we can see the numbers in the US as here. It's not 80 or 90%. It's still only 60, 70%, depending on the age group. Mm-hmm. What have you seen in the lab that underscore the importance of vaccination?
This is a great question. And I think I know I've convinced at least one person to get vaccinated. So that's my track record of family members. But I think that really came from explaining how the vaccines work, and sort of showing that like you can't get COVID from the vaccine, it can't cause disease, and the thing it can do is protect you from severe disease and death. And so I use those graphs that I showed, where you can really see, the vaccine number of cases and severe disease in vaccinated people is, basically zero. Of course it isn't actually zero, but, very close. And then the curves for unvaccinated people is much higher. And so I think for me, the risk of severe disease and death is the most convincing in terms of what we've seen in the lab. The vaccines are very effective at inducing immune memory, and that immune memory looks very similar for the most part with infection-induced immunity. And so because they come without that risk of severe disease and death and generate very similar immune memory and components, multi-layered components of immune protection, then I would say it's definitely the better option.
Well, I think on that note, I want to thank Dr. Lauren Rodda for talking to us this morning and this evening from the States about this issue about vaccination. And I think the message is clear. Get vaccinated. Even though after vaccination, I think you can still get it. I think I found that out myself a month after getting my third booster. Still got COVID, but it was so mild, I hardly felt it. And so I wonder what it would have been like if I had not gotten boosted. I would have been a lot sicker, I think. And so I highly recommend, let the science speak for itself. So encourage all those who can. I know not some of you cannot, I think for whatever reason, health reasons, but those who are able to, please get vaccinated. And the one numbers I'm taking away from this talk is the 20 million lives that has been saved because of vaccination. This is unprecedented for the globe, for the world to define the vaccination so quickly. I remember my first couple of talking to Dr. Ben Cowling. He was predicting that Hong Kong, we might be getting a vaccine for COVID in 2 or 3 years. And he was proven wrong. In less than a year, we had the vaccine. And then I think the numbers speak for itself, 20 million lives saved. So that's one reason we continue to do this program. We're going to, hopefully, we will taper off as now that I think we're all kind of living with it. And then maybe next year, we're going to do less of this program, but still bring you more up-to-date information as we get them, whether it's from the US or Hong Kong or the rest of the world. So again, thank you all for joining us. And thank you, Dr. Lauren Rodda, for joining us from Seattle, and keep up your great research. And we look forward to perhaps welcome you back to tell us more what you're doing in Washington. Thank you all and have a great day.
Thank you.
Bye-bye.